Calculus AB, Tuesday, February 7th. Integration using substitution, okay? So yesterday we talked a lot about the reverse power rule. So if I'm trying to integrate like 6x squared with respect to x, what do I do to take that antiderivative? Right, so the regular power rule for derivatives, right? We multiply the exponent and the coefficient together, and then we subtract 1 from the exponent, right? When we're doing antiderivatives, we have to do everything backward. So what do I do for the reverse power rule? I start by adding 1 to the exponent, and then I divide the new exponent. Or I divide the coefficient by the new exponent, right? So this becomes 6 over, so this becomes, right, 6 times over 2 plus 1 times x to the 2 plus 1, or just 2x cubed. What am I missing? What do I need to write here? Plus c, yep. If you don't write plus c, you'll get a c plus. Yeah, that was what Mr. Shaddy always said. So, yeah, we're on 6.9.
Wait, what?
So do you remember, how do we check our answer? How do we make sure we took the correct antiderivative? How do we do that? Take the derivative, yeah. So the derivative of this will be what? 6x squared, yeah. And this constant can be anything. It can be 1, 2, 3, 4, 5, 6, right? So technically there's an infinite number of antiderivatives because I can make this constant whatever I want and it'll have the same derivative, 6x squared. So mathematicians write plus c to, yeah.
Like when they're
When you're doing this is an indefinite integral. When there's no like numbers on the top and bottom here, you have to write a plus c. Yeah. So when you come in for help, I can explain that too. Okay, so that was the reverse power rule. What other rules do you think get reversed in the chain rule? Yes. So they call it U substitution. I've always thought of it as the reverse chain rule. Okay, I've always thought of it as the reverse chain rule. All right. And here's how I think of it. Hopefully this helps, okay? So this method's called U substitution. It's called a U substitution. I'm just going to call it a U sub, okay? Use it when you see a function with the derivative of what's inside right next to it. That's like what tips you off. Okay. All right. So right here, right, 2x times x squared plus 1 to the 4th. Do you guys see how the derivative of everything inside these parentheses here is 2x? Right? And that 2x is right next to it, right? There's everything, okay? You seeing that? Okay? So when that happens, what you want to do, the way to actually do it, you want to set u equal to the stuff inside parentheses, or inside your square root, or whatever. Set u equal to, it's a variable, stuff inside parentheses, or like square roots, or a trig function, okay, or natural log, okay. Right. So we're going to set u equal x squared plus 1 here, okay? U equals x squared plus 1. All right? The next thing I have to do is I have to take the derivative of both sides of that u equation that I just wrote. I have to take the derivative of that with respect to x, okay? So I'll have du dx equals what? 2x? Yep, 2x. So this line right here is the derivative of what's right above it. Okay. Multiply both sides by dx. So this is horrible mathematical reasoning, but this is how physicists will explain it to you. Multiply both sides by dx, you get du equals 2x dx. So I highlighted stuff in yellow and I highlighted some stuff in pink. Why did I do that? Matches, right? So I can rewrite this integral as the integral of, what does that x squared plus 1 to the 4th become? Becomes what? If I u to the 4th. And what does that 2x dx come from? Or what does it become? Du, okay? Can you guys take this antiderivative here? Antiderivative of u to the 4th is what? 1/5 u to the 5th. Right, plus c, okay? And then the last step is just plug this u back in, okay? Plug your u back in, okay? So your answer is 1/5 x squared plus 1 to the 5th plus c. That's my answer. I'll highlight it in green. All right? Any questions about what I just did? All right, so I was tipped off to this method. I saw a function inside of like some parentheses with an exponent, or I could have seen it inside of a square root, or inside of a trig function, or inside of a natural log, right? And I saw the derivative of what was inside those parentheses right outside those parentheses, okay? That's what tips me off to use u substitution. I always set u equal to the stuff inside my parentheses, take the derivative, multiply dx over, and then I substitute everything in. Gives you a much simpler integral, okay? Take the antiderivative, plug your u back in, okay? We don't want any u's in our answer, okay? Just in our work. You guys feeling okay? All right, what do I set u equal to for this next one? So u is going to be x cubed plus 1, okay? And I came up with that, Nick came up with that because he saw a function inside of a square root symbol, and he saw the derivative of all this right outside. Okay? I do what at this point? Take the derivative. So du dx is going to equal 3x squared. All right? Multiply that dx over. Again, that's horrible. Don't tell a mathematician that I did this, okay? If you have a friend who's a mathematician or like a parent or uncle, don't tell them, or an aunt. All right? But yeah, physicists will explain it to you that way. They don't care as much about the rigor of mathematics. All right? And then what can I rewrite my integral as then? So it's going to become square root of u du, okay? So this 3x squared and that dx, they became du. The two of those multiplied together became du. And the stuff inside the square root became a u, okay? This is antiderivative of u to the 1/2 du. All right, and if I do reverse power rule, that gives me 2/3 u to the 3/2 plus c. Okay, we don't want any u's in our answer. So sub back in whatever expression you set u equal to, okay? That's a u sub. U sub. All right, this is my promposal, okay? No. So do you guys remember u sub from algebra 2? No? Okay, well, it's fine. You don't need to. All right, is that okay? All right, what should I set u equal to for the next one? Look behind you, they would like to share a photo. Probably decline. All right. U equals what? U's going to be what here?
10x plus 3.
10x plus 3. Yep. Why do we set u equal to that? We saw a function inside of parentheses and its derivative, right? The derivative of tangent is secant squared right outside of those parentheses, okay? All right, they're still trying to do it. Okay, I take the derivative of both sides, I get what? You'll see that the derivative just becomes the stuff that's outside. So secant squared x. Okay, so du equals secant squared x dx. All right, so this integral becomes just u du, right? antiderivative of u du. If I use the reverse power rule, I get what? 1. That's the derivative of u. What's the antiderivative of u? 1/2 u squared plus c. Okay. How did I just get u? So the tan x, right? This tan x plus 3, that becomes just a u, right? Okay. And then the secant x and the dx become du.
The 1/2 u squared is from the u. What about the du?
Like where the du come from?
Where's the derivative?
It's right here. Du dx equals secant squared of x.
Yeah, so then when you then go down and do the antiderivative.
Yeah, the du just goes away when I do the antiderivative. So this is just a notation thing. Du, what that means is you're integrating what's in here with respect to u. The du is just a notation thing. It tells us what our variable of integration is. Right? So I can't do, it's mathematically incorrect to do like the integral of u dx. Like it's not mathematically correct to do that. Okay? The answer to this would be u times the integral of dx, which would be ux plus c. Okay? The integral of u du would be 1/2 u squared plus c. Okay? So the integration variable tells you what variable to take your antiderivative with respect to, right? Imagine it like this. If I had like x squared plus y squared equals 2x, okay? Say I took the derivative of both sides of this equation with respect to w. What would I have? Just 0 equals 0, right? Okay? So the du just tells us what variable we're integrating with respect to. So it just goes away when we take the antiderivative. You need to make sure it's there before you antiderive, but it goes away when you antiderive. Yeah. So. And then what's my last step here? I can't have any u's in my answer, so I do what? Yeah, tan x. Okay. All right. Sometimes du dx is not a. So these are 3 simpler ones, right? That's just like the most basic u substitution. Okay. These 3 down here, right? We have to do, sometimes you have to fiddle around, right? So, a little comment. Sometimes you have to, fiddle around to make your u sub work, okay? Right? It's hard, guys. Sometimes you got to make it work, okay? All right. So this would be a u sub here if I had what outside? 2x, right? Because I have parentheses, a function inside parentheses, right? Its derivative is 2x, but all I have is an x here. All I have is an x right there. How do I get there to be a 2 there?
Multiply it by 2. Multiply the
So yeah, so I can put a 2 there. I can put a 2 there, but what do I have to put outside the integral to compensate? A half. Yeah. Right. And I'm allowed to do that algebraically, right? Because I can multiply something by 1/2 and by 2, and all I'm doing in the end is multiplying it by 1, right? To do a u sub, you need the derivative of whatever's inside your parentheses to be right next to them. I had an x here, I need a 2x, right? So I need there to be a 2, okay? So now I can do a u sub. So u equals x squared plus 1, du dx equals 2x, du equals 2x dx. So this becomes 1/2 times the integral of, what is that, u to the 6th du, or just 1/2 times 1/7 u to the 7th plus c. 1/2 times, okay. Yep. And then that becomes 1/14 u to the 7th plus c. Do you guys see when I distribute 1/2 times c, I can just rewrite it as c. It's an arbitrary constant, so. and then plug your u back in. You get 1 over 14 times x squared plus 1 to the 7 plus c. Integrals. Are you feeling okay so far? This next one, so I have a function inside square root. What's the derivative of all that stuff that's inside the square root? It'd be 2. Yeah, derivative of that would be 2, right? So I need there to be a 2 outside here. So what do I write? I can write a 2 there, but to compensate I have to write what outside? A 1/2. A 1/2, okay? So that becomes, and then what am I going to set u equal to? 2x plus 1, so du dx. 1/2 times the integral of root u du. Okay, that's the same as 1/2 times the integral of root 1/2 du. Take that antiderivative. I get 1/3 u to the 3/2 plus c. Sub back in for u. I get 1/3 times 2x plus 1 to the 3/2 plus c. Okay, you guys feel okay about this? Sometimes you have to fiddle around. You have to make it work. Okay, so you guys are going to spend the next 4 years doing a lot of integrals. Actually, you're probably not, unless you're a math or physics major.
Richard.
Are you going to be a physics major?
No.
Math?
I'm gonna do biomedical engineering.
You have to do some. You have to do some. You have to take physics. I come back at 12:45. Yeah, I'm trying to skip that line too. Sorry. Do you know
No,
Robert
nothing, man.
Kennedy Jr.? Oh, this next one. Oh, this next one's a good one. This next one's a good one. Oh, what do you guys think I'm gonna end up setting u equal to?
4x squared minus 5.
Yes, I'm gonna end up setting u equal. Oh, that's so good. U equals 4x cubed minus 5. Yep. 4x cubed minus 5. What's the derivative? So what's du dx? That's going to be what? 12x squared. Okay, so du is going to be 12x squared dx. Okay. All right. What do I have on top there? I've got a 7, right? I've got a 7. I need that to be a 12. I need that to be a 12. Okay. So let's rewrite that as 12x squared, 4x cubed minus 5. Let's pull the 7 out, okay? Then what do I need to put out here to compensate for the fact that I put a 12 here? A 1 over 12, okay? So what I've got, the fraction that I end up having on the outside there is a 7 over 12. Okay? I pulled the 7 out. I stuck a 12 in my numerator. I've got to write in a 1 over 12 to compensate. Okay, so combining those two, I've got 7 over 12. Okay? So then this becomes 7 over 12 times the antiderivative of du over the square root of u. Okay? Let's rewrite that as u to the negative 1/2 du. Right? And then let's do the antiderivative.
2u to 1.
What is that? 2u? Or would it be u to the 1/2? It would be negative 2. Or it would be 2, u to the 1/2. Yeah, plus c. Okay. So that becomes, what? 7 over 6 times the square root of u plus c, or 7 over 6 times the square root of 4x cubed minus 5 plus c. All right? So I start with a 7, right? I want that 7x squared. It's going to be a 7. I want it to be 12. Squared root of 7. Okay. I can do that. So I'll pull this out now. I'll go over 12 back here. Compensate for 12 back here. Right, that was 7 times 12 is 7. All right, you can perform integration by substitution for more complex trigonometric functions as well. These actually aren't too bad. They look scary, but they're not too bad. That first one, what do you think I'm going to set u equal to for that first example?
2x.
Yeah, so I've got a function, right, that 2x, right? It's inside of a sign, okay? So u is going to be 2x, okay? Du dx is going to be 2. Here, du is going to equal 2 dx, right? So, right, I can put in u just fine, right? What do I need to make sure there is on the outside here before I can sub in du?
2.
I'm missing a 2, right? So let's put a 2 there. What should I write in front of my integral to compensate? 1/2. So it's going to be a 1/2 times the integral of sine u du, okay? What's the antiderivative of sine? The derivative of what equals sine? Negative cosine. So it's going to be 1/2 times negative cosine u plus c. Okay, so negative 1/2 cosine x plus c. It's all coming back, okay? Trying to help kid with geometry this morning. Haven't done geometry in like 7 years. Actually, since freshman year of high school, so what, 10 years? Yeah, like exactly 10 years. But she couldn't really help her. She could come to me to do some antiderivatives. Oh, what's up?
Is it cosine 2x?
Oh, 2x, thank you. Sorry, forgot to write the 2. Thank you, Hayden. Alright. What am I going to write u equal to this time? Theta over 4, right? Then du d theta equals 1/4. Okay. Du equals 1/4 d theta. Okay. So I needed there to be what fraction on the outside here? I need a 1/4, right? So okay, so
Wait, what?
I want to sub in du up here, right? I can just slap the u in there, right? But I want to make sure I can change, I guess I can sub in a du up here, right? I can't sub in du directly for d theta. I can only sub it in for 1/4 d theta. So I need it to be a 1/4 right now. What do I need to insert on the outside of that antiderivative symbol then? So I'm going to have 4 times the antiderivative of cosecant squared u du. Okay. The derivative of cotangent is negative cosecant squared, right? The derivative of cotangent is negative cosecant squared. So I'm going to make my life easier if this is negative, so I'll put a negative there. If I put a negative inside here, what do I have to do to compensate?
Negative
I need to do a negative outside. Okay. I can't change I can't algebraically change the value of anything, okay? So you can multiply something by 1, right? You can multiply something by -1 twice, right? The same thing as multiplying it by 1. All right? So then that's -4. Taking the antiderivative, you get cotangent of u plus c. Or -4 cotangent theta over theta over 4 plus c. You guys doing okay?
Why is it negative?
So if you look at your pink sheet, there's no trig function on your pink sheet whose derivative equals cosecant squared. There's only a trig function whose derivative equals negative cosecant squared. So it's a lot easier to take this antiderivative if it's a negative. You can make it a negative as long as you put a negative outside. It's classic. Right here. Here. Example 4. What's going on there? What should I make u equal to?
3x.
Thank you. So I've got a sine 3x, right? That's a function, right? It's inside. So technically, right? I don't know if you guys want remember this, but sine squared of 3x. That's just notation. That's just fancy notation for sine of 3x squared. Okay. So you've got a function inside parentheses, right? With its antiderivative right outside, right? Cosine 3x. Okay. So that's what ticks me off to set u equal to sine 3x. So then du dx is going to be 3 cosine 3x. Okay, so du equals 3 cosine 3x dx. Okay. Alright. So, right, subbing everything in, right, this integral is going to be equal to u squared But then to sub in du, right, I can't just plug in du for cosine 3x dx. I need what to be in front there? You have 3 in front, right? So let's put a 3 in front here. What do I have to put on the outside of that integral to compensate? 1/3. Yep. It's going to be 1/3 u squared du. Okay? It gives me 1/3 times 1/3 u cubed plus c. 1/9 u cubed plus c. 1/9 sine cubed of 3x. Why did I put the 1/3? I put the 1/3 there because I put, which 1/3 actually? This one or this one? The one on the right or left?
The one on the top.
Right here. So I need there to be a 3 here. Because I want there to, so when I'm rewriting my integral in terms of u, with only u's, I want there to be a du there. Du equals 3 times cosine 3x dx, right? All I have here at the beginning is cosine 3x dx. I'm missing that 3. So I have to put that 3 in there and then multiply by 1/3 to compensate. Yeah. Okay. Right. All right, then you can do it with exponentials too. Right? You can do it with exponential functions. Okay. So it's all the same process. So I've got a function inside of an exponential. So what do you think my u is going to be, right? I've got a function inside of another function. So what's my u going to be? It's going to be 3x plus 1. Okay? Du dx equals 3. Okay? So du equals 3 dx. Okay? This is going to be similar, Dainara. Okay? So when I'm changing this integral to be in terms of u, it's going to be e to the u. And before, right, to sub in du for dx, right? Du is not just equal to dx. Du is equal to 3 dx. So what do I need to have out here before I can sub in du? I need a 3 right there. Okay, and to compensate, I put a 1/3 in front of that integral. Okay, so it's going to be 1/3 e to the u du. Okay, what's the antiderivative of e to the u? Just e to the u. Alright. Alright, let's do B. Oh, fun. So I've got a function, right? Negative x squared. I've got a function here that's inside of another function, right? It's inside an exponential. What am I going to set u equal to? What have we been doing the whole time? Yeah, we've been doing that. We've been setting equal to whatever function is inside the other function. So u equals negative x squared. Okay. Du dx then is negative 2x dx. D just negative 2x. Then du equals negative 2x dx. Okay. So subbing in, I get, okay. So subbing in for u is going to be easy peasy. That's just e to the u, right? Subbing in for dx, right? Right outside right here, I've got a 5x. I need that to be what to sub in for du? I need that to be a negative 2, right? So I think the easiest way to do this, okay, let's pull the 5 out. Okay, so we'll have 5x e to the negative x squared. Whew. We learned how to, nah, I won't do that one. Nah, can't just keep telling stories the whole time. And then I need this to be a negative 2 right here, right? So let's put a negative 2 there. And since I put a negative 2 there, what do I need to put right here outside to compensate? And times negative 1/2. Okay? So it's going to be negative 5/2 e to the u du. All right? Take that antiderivative. Write that down. e to the negative x squared comes up a lot in statistics. Very, very important function. Is anyone in stats right now? Yeah, so like the normal curve? Normal curve proportion to negative x squared. Up to a bunch of constants.
Yeah, we haven't gone into the calculus.
Yeah, you probably won't, not at Cathedral, but yeah. This next one, e to the one, whew. Okay. What do you think? What should I set u equal to?
X to -1.
X to the negative 1, yeah. So I've got a function 1 over x, right? That's inside of an exponential. That's inside of an exponential, okay? I'm going to say u equals 1 over x, then du dx equals negative 1 over x squared. So I can sub in for u, no problem, right? But what do I need? So what do I need right here before I can sub in du? It needs to be negative, right? So I'm going to put a negative here and then a negative out there to compensate, okay? So it's going to be negative e to the u du. Negative e to the u plus c when I take that antiderivative, and then subbing back in for u. Alright, so you guys see that it's like the same process every time. The functions that we're dealing with are different, right? The functions and their antiderivative are different, but it's the same process. And then sine x e to the cosine x. What am I going to set u equal to? Cosine x, yeah. Okay. So I can sub in for u just fine. What do I need, right? So I have a sine x dx. To sub in for du, I need this to be a what? It needs to be a negative, right? So I'm going to put a negative on the inside and the outside. So it becomes negative antiderivative of e to the u du.
So when you take the cosine x, you don't do anything.
No. I end up copying it over when I sum in for u, but yeah. So that's negative e to the u plus c, negative e to the cosine x plus c. Okay. That'll be at the top. Okay, so let's get through this natural log stuff, okay? So here's another example of u substitution, okay? So the derivative of write this on the board here. So if I have a function u, if I have a function u of x, okay, the derivative of the natural log of u of x, okay, it's going to be what? Do you guys remember from last semester? It's 1 over u, right? Then times u prime for the chain rule. So it's going to be u prime over u, okay? So going backwards, anti-differentiating, doing an antiderivative, whenever you see a function of the form, a function with its derivative on top of it, that's just the natural log of whatever is on the bottom. Okay? So 3x squared minus 2x, what's its derivative? 6x minus 2, right? So do we have a function with its derivative right on top of it? Yep, so all I have to write down here is natural log, and it actually has to have an absolute value symbol. Natural log of the absolute value of 3x squared minus 2x plus c.
That's the answer.
That's the answer. Yep. What do we have over here? What's that going to be? Yeah, so the derivative of tangent is secant squared, right? We've got a function here. It's a function with its derivative right on top of it. Okay? With its derivative right on top of it. Okay? So this is going to be the natural log of the absolute value of whatever's in the bottom. So it'll be ln absolute value of tan x plus c. All right. Okay. All right. So this is changing gears a little bit. We're still doing U subs. We use these three formulas all the time when we're doing integrals. Okay. We use these three all the time. Okay. So there's going to be a lot of functions, right? You're trying to take the antiderivative of this function. If you can get it in one of these three forms, then you can use these three formulas, right, to get your answer, okay? Arcsine, arctangent, and arcsecant. Is that arcsecant? I guess it is. Okay. I always thought it was arccosine in the back of my mind. So yeah, so let's do some problems with it, okay? So let's keep these in our back pocket, okay? Keep those three in our back pocket, okay? Yeah. Oh yeah. These will need to be memorized. So pink sheet these at some point. Pink sheet. All right. You can do that on your own time. All right. Find each of the following integrals. Okay. So I've got d dx of the integral of 4. All right. Yeah. I've got integral of square root of 4 minus x squared. Okay. So let's pull our formulas out. Which one should I use? Which formula up here does this problem look the most like? What's that? Arcsine, right? What's my a? 2, right? Because 4 is the same as 2 squared. So a equals 2. What's my u? It's just x, right? So my answer here is going to be arcsine of 2 over x plus c.
What's that?
Hmm? Yeah, sorry, x over 2. Sorry. Thank you. I just do that on purpose just to make sure you guys are paying attention. No, I'm kidding. Relax. Okay. Let's do another one. Okay. Dx over, what is that? 2 plus 9x squared. Okay. So pulling out my formulas here. Right? Which formula does this problem look the most like? Looks the most like arctan, right? What's my a going to be? Square root of 2. Okay, what's my u going to be? 3x. Okay, so it needs to be, it looks the most like arctangent. This problem looks like the most like the arctangent formula. but I need to do a little bit of algebraic manipulation to rewrite it in the exact same form. So this needs to be dx over a number squared plus another number squared, okay? 2 is the same thing as the square root of 2 squared. 9x squared is the same thing as 3x, all of that squared, okay? So that's where I got my a and my u from, okay? So my answer is 1 over a, so 1 over root 2 times the arctangent of u, 3x, over root 2, plus c. Okay? Let's do one more, then we can stop. Which formula does this one look the most like? Arcsecant, yeah. So dx, is that 4, or x? So this problem here looks the most like my arcsecant formula, right? It needs to be of the form du, so dx over a number times the square root of that number, same number squared minus a squared, okay? What's my a going to be then? 3, right? Because 9 is 3 squared. Okay. What's my u going to be? Nope. Yeah. Right. 4x squared is the same thing as 2x in parentheses squared. So u is going to be 2x. I need this to be a 2x then, right? How do I do that? How do I accomplish that? So there's going to be, I'm going to multiply my integrand here by 1/2, so I'm going to put a 2 down here, and I need to put a times 2 outside to compensate, okay? Now I'm in that form. I can write down my answer. 1 over 3 arcsecant absolute value of 2x divided by 3 plus c. Don't forget I multiplied by 2, so this needs to be a 2/3. Okay, there you go. That's my answer. All right, any questions? We'll stop there today. You guys have enough on your plate for tomorrow, so let's hold off on more skill builders. And you guys don't need to take many quizzes tomorrow. You guys take care.